Hey guys, this is Bob Morelli with the Tuning School, and today I'm sitting here talking with Eric Radzins from ACI Procharger. Eric handles all the calibration and tuning work. So when you purchase a kit from Procharger and you get the tune that comes with it, Eric's the guy that handles all the work to make all that happen. So welcome, Eric, and thank you for joining us.
Hey, not a problem. Thanks for having me.
Yeah, absolutely, man. So I'm just going to kind of go through a couple questions with you regarding centrifugals, and I'm kind of hoping that we can chat and get a little more in-depth information out there for the guys, who are looking to maybe build a system or who may already own a system and then want to do some improvements. So, Eric, let me ask you, why go centrifugal over another type of power adder? Something like a positive displacement blower or a turbo or something like that.
Really, I think it boils down to the simple things that everybody thinks about: ease of installation. Um, cost is a factor. Obviously with a bolt-on centrifugal blower kit, it comes in a box. You bolt it on the car. You don't cut anything. You don't fabricate anything. Load the hand. Well, if you bought a full system, you load the tune that comes with it that we provide you, and usually by the end of the afternoon or later that evening, you're out rocking and rolling and having a good time.
Sure.
I do believe that centrifugals are a really good natural power curve for a street car, well, and race cars too, but cars today already make plenty of power to spin the tires, peel out, and do all that. I mean, the Hellcat's a great example. 700 horsepower, 80% of the people that own it probably would get beat by everything that makes half the power.
Yeah, it's true.
The car's very good at spinning the tires, but unless you have really good traction, hard to make it a very fast car. Where kind of one of the benefits of a centrifugal is you're not going to get that huge surge down low where you don't need it, but you're going to get all of the mid-range and the top end where you actually do want it when you actually have traction and you're in the correct gear and stuff like that. So it's very natural how the power comes in and very controllable.
Sure.
Half throttle is still half throttle, three-quarters throttle is still three-quarters throttle, and full throttle is all the beans.
Sure, absolutely.
It's a good driver's power adder.
So a serious guy might be more inclined to go this route, who's maybe doing some road racing, autocrossing, I don't know, something like that.
It is, yeah, absolutely. I've over the last year or so, I've seen more and more guys really starting to road race centrifugals, and knowing they're now seeing the benefits of them, the cooler air temperature charges, there's no power fade lap after lap, so it's something they can really count on having a very consistent power,
right?
Especially in a road racing condition, or if it's a street car guy and he's out having fun on a Saturday or something, and some spirited driving, in a closed course.
Close course. Mexico, you mean?
Yeah, Mexico.
Yeah, Mexico.
Say you happen to be flooring it multiple times back to back to back. Well, again, with the centrifugal, there really is hardly any, if at all, power fade between those runs. So it's not like something where you have a good power run and then you got to ice it down for 10 minutes.
Right. So, or it's not like you have issues where maybe like a positive displacement under a hood, is getting heat soaked. Or it could be a nitrous bottle that needs refilling. I mean, there's ups and downs on all these different types of
absolutely.
systems.
Everything's got a benefit and stuff like that. Though we touched on it when we were chatting earlier. I need to turn that off.
You're just super cool. You got lots of people contacting you.
Yeah, no, it's when you forget that your ringer's on. Nobody calls you for 3 hours. And all of a sudden now you get it. With modern transmissions, having 6 speeds, 7 speeds, and 8 speeds, the OEMs have made it really awesome for a centrifugal blower now, because every time your foot gets into the throttle, the transmission automatically puts the car way up into the power band, into the usable horsepower area. So the day and age of having 4-speed transmissions with big power gaps in the RPM every time a gear change would happen, those days are gone.
Right.
And I'm sure you can agree those probably aren't ever coming back.
Yeah, I don't see that happening.
No. Nobody's going to be like, hey, that 8-speed was a real good idea. Let's go back to 4.
Let's go back to 4. We wanted 4. Yeah, no. Yeah. Maybe just a power glide. Maybe let's just go to that.
Yeah, absolutely.
Yeah. I don't think that's happening. So what do you think of the different the different types of blowers. Like say you got something that's oil cooled versus self-contained. On a centrifugal.
Well, so Prochargers, I mean, they patented doing a self-contained centrifugal. I'm probably wrong on this date. They'll probably yell at me, but I want to say like 99, 2000, something like that. So we've had like 15 years of doing self-contained. Mm-hmm. The benefit of the self-contained blower has always been pretty easy to look at. If an engine had a failure mm-hmm. and the supercharger is getting oil from the engine, the last thing you want is metal to then go through the blower and ruin the blower as well.
Right.
I guess the flip side to that is also if there was something that ever happened to the blower, you don't want the metal to go through the engine.
Right.
So
yeah.
Same, a turbo or anything like that. Mm-hmm. So keeping them separated from each other has been a great idea from a longevity standpoint. It also keeps, obviously the oil in the engine gets dirty mm-hmm. very quickly from fuel contamination and just general wear. The blower doesn't have that much wear internally. Once they're broken in, which we do here before they ship, there really isn't much going on inside of them as far as, there's no fuel. They don't really shed anything. So the blower is much happier in its own oil for long, long periods of time. We have you change the oil about every 6,000 or so miles, mm-hmm. Just to kind of keep an eye on it. But mm-hmm. then again, it probably could go a lot longer than that. But that is just a safety net, you know.
If you're doing something like road racing or really abusing the thing, do you guys recommend changing that oil more frequently?
Nope.
Okay.
Still doesn't matter.
Okay.
Again, it just comes down to there really isn't that much going on. Really, I don't even know how to answer that. I mean, frankly, they probably could be in there a lot longer, but people already had a hard time believing that they could last 6,000 plus miles.
Okay.
So I guess if you told them it would be 20, then they would look at you even weirder.
They'd freak out. But, you might as well just change the oil and be happy.
Yeah.
I gotcha.
Which nobody. I mean, we tell people every other oil change that you're doing on the car. So I guess if you are road racing it and you're beating on it and you're going to be changing oil, I mean, if you're doing that, do it every 2 times. Kind of keep that same pattern.
Sure. Well, that makes sense. That would make a lot of sense. So,
yep.
So are there any mechanical benefits of oil versus self-contained, of oil fed, or is it really not going to affect the operation of the unit?
No, not necessarily. There really isn't a huge effect in it. The blowers can run cooler when they have their own oiling system on board, depending mm-hmm. on the car's application. Some vehicles, I'm sure you're aware, run really high oil temps mm-hmm. just based on the design of the motor, and others don't. So if you had a car like I don't know. I mean, I know Volkswagens, for example, running very high oil temperature on them. If you had one of our blowers on it, there's no reason to spray 240, 260 degree oil on a supercharger if you don't need to.
Right.
So when the blower is self-contained, it never gets that hot.
Okay.
They kind of get to their happy temperature somewhere around the cylinder head temperature just because of the nature of the aluminum.
Right.
Transfers heat, and basically whatever the cylinder head temperature of the motor is kind of what the gearbox gets to.
Oh, that's cool. Did not know that. I always wondered about that.
Yeah, it's just the heat transfer. I mean, the temperatures inside are a little bit different, but when you have an aluminum head with an aluminum bracket mounted to an aluminum gear case, it's just a matter of time before the temperature just kind of creeps itself over.
That makes perfect sense. So, speaking of the blower itself, let's talk a little bit about the trims, like P, D, F. Talk about those just a little bit for me.
Okay, I know the internet always thinks that there's some magical verbiage that goes behind those, but there really isn't. I mean, back in the day, the P blowers were the first blowers around for Procharger, so hence the P.
Okay.
And that kind of started the entry level. D, I think, came from back in the 90s for Dominator, Domination, or something like that. I believe it was Dominator.
Okay.
And that's just kind of stuck around. And then the F would be your Tornadoes or something, because we are based out of Kansas City, which we're very proud of.
Gotcha. Tornadoes and barbecue. Is there going to be a B somewhere along the line here for barbecue?
There is a B for the Harleys for bikes.
Oh, okay. And that's just lame. We need to get something for the cars, man.
Yeah. I mean, we have A's, B's, F's. I mean, there are quite a lot of them. Not everybody sees those blowers because they're not around them. So
right. So what's the main difference between a P and a D and an F in those trims?
Okay, so a P, there's a few variations of a P, mm-hmm. and then there is really only 2 of a D, the old school oil-fed blower from back in the day, which we don't sell anymore, but we still service them and maintain them. And then your D1 SC, which would be the self-contained version of that blower. The Ps have a couple different trims based on the cars that they were originally intended for. Back in the day, we had to basically trim down the blowers so you wouldn't have an overboost situation on cars like 96 Cobras. That was a real high RPM spinning motor, and they really didn't like much boost back in the day, so we had to trim the blower down a little bit. Those, however, all pretty much been phased out with these new generation motors, because most modern V8s are making for 350, 400, 450 horsepower more. So now our base blower would be a P1SC-1, which is basically the brother sister to the D1SC.
Okay.
It's the blower that the California Air Research Board for emissions has deemed like that as our entry level blower, and that blower has the same boost curve, same characteristics. It's basically identical to a D1SC, just a touch less.
Okay.
So if you pulleyed them for the same boost level, they would inherently overlay each other. They would look identical.
Okay.
One would just be like a pound or so, 2 pounds higher than the other.
Okay.
So that's one of the internet myths, is that you can't make power with the P1SC-1 and you have to get a D1SC, which isn't completely
right.
Not true.
Right.
All you need to do is just put a little bit smaller pulley on the P1SC-1 to up the blower RPM just a tiny bit, and then the curves will actually match. They'll be identical. So
okay.
For guys to say that there's more mid-range with one than the other, 100% false.
Okay.
They are
very
totally
similar.
identical.
Very similar.
That, however, all changes when you get into the F-Series. The F-Series starts a change inside of the gearbox where there's actually compound bearings, more robust gears on the inside. So the cases look the same externally, but on the inside they're 100% different.
Okay.
Most of the F-blowers get used in racing applications or stuff, I'd say 700 to 1,600 horsepower is the range, but
That's
your
the range.
street guys would be the 700 to maybe 1,100 range. That gearbox is loud. I mean, you
whistle?
know when a guy has a Procharger F-Series blower. There's no mistaking that sound.
Is that just the cut? Is it the cut of the gear? You think that's what makes that noise?
It's a straight cut gear.
Yeah.
So that way the keeps the side load down on the bearings.
Right.
Whereas stepping back, a P1SC or a D1SC you can get in straight cut gears if you do want a loud blower, or a helical cut gear, which is a lot quieter.
Okay. So a P or a D.
Stealth or sleeper mode there.
Right.
And a guy can make, I should say, we got guys making 800, 880 to the tire with D1SCs, quiet, basically being a sleeper. So it's usually the guy 700 and above that'll move to the F-Series, but it's usually more 800, 900,000, whatever.
So really big power output, not your average street car.
Yeah. Pretty much the guy for the 4-digit power number.
Yeah.
4-digit power number club.
Right.
Not saying you can't turn down an F, but just saying if you were going to do that, you might as well just get a D1SC.
Get a D1, yeah.
So with the F, we make tons of different trims, and I guess what I would love to say is give us a call if you don't know which one is best for your application. We got a huge phone staff, lots of technical guys here. I mean, everybody downstairs is, got some kind of vehicle that they race, or the trend of everything's got an LS swap in it, but it's kind of funny.
Wow, that's awesome.
I can tell you what would be the perfect blower for what you're trying to do. I tell people it's unfortunate that we make so many blowers, it's hard to explain, but we're fortunate that we make so many blowers because we truly can find the right one for what you're trying to do.
Right. That makes
so
sense.
If a guy, say you had 2 cars, for example, both have a power goal of about 1,000-ish horsepower, and one's a stick and does roll racing, and the other guy is an automatic power glide with a 6,000, or not 6,000, but like it's a 4,500 stall converter. Well, their power goals are the same, but
what they're doing is different.
We would spec them 2 different blowers based on what they're doing, so that the boost curves matched what's going to get them from A to B the fastest given their application. So that's my biggest thing is give us a call. We'll talk to you about it and figure it out. So sometimes the internet tells you that you should get a certain Procharger, but that might not necessarily be right for your application.
Sure. And I can understand that. So speaking of the call and talk about it, I would call and talk about the new variable ratio stuff that I'm hearing about, because I don't know that much about how it works. So like, how is that relative to a powerful street car? Is that something that they should consider? And what is it? What is it exactly, and should they consider that?
So, okay, everybody asked me that one, so
okay,
hopefully getting pretty good at it.
Okay.
Since superchargers came out, or at least centrifugals, way back in the war days, really everybody knew the benefits of them. The cool air charge, it doesn't take much power to turn one to make a given amount of horsepower. The downside has been how to control them.
Right.
Like a turbo can control its speed with a wastegate, and therefore controls impeller RPM. Mm-hmm. Whereas centrifugal's always been a fixed ratio. As the motor increases, the impeller spins faster. So really kind of the holy grail that everybody was trying to find was, how can we control a centrifugal supercharger impeller RPM much like a turbo mechanically? Mm-hmm. So lots of versions have been tried in the past. Thankfully, technology has evolved in control systems and stuff like that. So we actually had the ability to create one. And this new blower, the I1 is what we call it for intelligent.
Ah, okay. There we go. A new letter.
Yeah.
A new letter.
Yeah, there you go. A whole new one.
Okay.
The I1 takes a CVT transmission, much like you'd have inside of, modern cars that have a CVT transmission, or a snowmobile, or anything else that basically can move its internal gear ratio for given loads and stuff like that. So the blower can control its impeller speed to basically make the boost number you want.
Nice.
Or the boost curve, I should say. So boost number or the curve. So unlike a turbo, where for the most part, unless you have a fancy boost controller, is going to come up spool and that's what you get. Or a roots blower instantly comes up and pretty much levels off. We can actually allow the customer to custom tailor how you want the boost curve to come in. Like, do you want it to ramp up like a centrifugal and then flatline? Do you want it to come in instantly? Or, I don't know, you can make an arch out of it if you wanted to.
Right.
I don't know why you would, but...
Well, you're talking about a Honda. That's theirs with a turbo. It's over.
Yeah, exactly. Yeah, I guess you could make that if you wanted to.
Yes.
But really what it was is, once, like I said, technology is what it is, we're able to look at all sorts of different engine parameters, throttle inputs, load inputs, RPM, all kinds of factors. All that goes into a processor that controls the blower, so that way it predicts what's going on. So that way, every time your foot goes down, you're going to have that instant boost, and it'll go right to where you're programming it. It was a really neat project. I mean, it was 5 years worth of development to make it what it is today.
So you had to build your own PID controller then?
Yes.
Wow.
Yep.
Okay.
Yep. So, we talked about earlier is the blower inherently learns the natural airflow curve of the engine. So the blower basically, when we're designing them and programming them, the blower will try to maintain basically 1 pound of pressure, and it watches what it takes, how much ratio and RPM of the blower to make that 1 pound. And then it'll basically step up a little bit. You can do 1 pound, 2 pounds, whatever, 3. But the point is to do little tiny amounts of boost. That way it's learning what the curve is. Once it learns what the curve and airflow of the motor is for given RPM points,
right,
the computer program in the background builds a 3-dimensional table, much like a VE table inside of a car's ECU. And that's how the blower knows where to be as far as its impeller RPM to give a given amount of boost.
So it's a smart blower is what you're saying.
It is. It is actually really neat how it works. It is very, very mind-boggling, and it's very fast at what it does. So the servo motor that controls the mechanism on the inside is all custom built to be as fast as possible and take the loads and heat and everything that it needs to do.
So would it be, and I'm sorry to interrupt you, Would it be correct to assume then that the tuning process would be tweaked a little bit with that type of blower, where you would maybe take your first pull and set it for 3 psi and then another one for 4? Do you need to kind of creep up on it that way towards your goal?
It is. If a guy's familiar with say they've done, say you're working on a 2011 Mustang and you've done a 2011 Mustang with either a roots blower or a turbo, most likely you're pretty familiar with what the timing tables need to be and things like that. So you should have a good idea of what it could do.
Right.
The beauty of modern cars with mass air meters and stuff like that is, I know a lot of people question, they're like, well, if you can change boost levels with the blower rapidly and boost curves, how does that affect the engine's tune?
Right.
Well, the good news is with a mass air meter on board, the car knows how much air is coming in, and it'll move itself to the correct points on the timing map and the airflow for fueling as well.
Right.
So really, once you pretty much tune it for what we call competition, which is pretty much everything, it's very easy to turn the blower down and have a car that still runs absolutely perfect.
Yeah, that makes sense. Like dropping the boost on a turbo.
Absolutely.
Yeah.
Yep.
Well, that's an awesome system. That's very cool. So that kind of leads me to my next question on sizing a supercharger. How can you correctly size a supercharger, and is there some math or performance goals, or how do you go about doing that with a supercharger?
Well, that kind of goes back to what I said about giving this a call. We have a huge phone staff, and I'm not making it up. I mean, there's a ton of awesome, smart, talented guys in the tech department and the sales department. So if you really what you need to have is a horsepower goal in mind. Like, what is your motor going to be capable of, and what is your end goal? With the turbo, it's a little different because you can look at a compressor map and the airflow and what it does. With a blower being mechanically driven, people can kind of artificially bypass what that compressor map is. They might not realize that they're shoving the blower into an area that isn't efficient. So what we'll do is
makes sense.
If you have the guy with the stick and you have the guy with the automatic, even though that you could have fairly similar looking compressor maps, we know which one would work best on that application. And we know how much it takes to make a blower flow a certain amount of horsepower. So to us, boost is kind of an erroneous number. I mean, obviously on a stock OE vehicle, it means more to us because we don't want to go over, like say 7 or 8 pounds on a C7. But on a built motor that has good internals, since the cam can move the boost number quite a bit, we're really looking at the horsepower number.
Okay. Airflow. You're looking for airflow.
Airflow. Yep. CFM. Yeah. So that's how we kind of spec things in, is what is the car going to be using for airflow needs, and that's how we get you the best one. So really, that's
pretty slick.
Calling in, knowing, what are basic things like the size of the motor, max RPM of the motor, cam specs if you got them. Not everybody has them, but at least let's get an idea or a ballpark of what we're dealing with, and we can usually get nearly right on the mark.
Okay. And
what's funny is we're not really shooting for a boost number, we're really shooting for a horsepower number, but therefore the boost number falls into play.
I understand. Okay.
And we can always move it around if we need to with pulley sizes, things like that. So
sure. Well, that kind of led me into my next question. Actually, was how do you read a supercharger's compressor map in that aspect?
It's basically inherently the same. I mean, it is. The only thing that gets tricky is when guys have, when you have an intercooler that doesn't flow what it should, and you can have this blower that you think you're going to be in one spot on the map, but then once it goes through a bunch of turns and bit twists on 3-inch piping and a really bad intercooler that came from who knows where, it might completely move it somewhere else in the map.
Right.
So really it comes down to, we know what blower you should have. 99.9% of the time it's absolutely perfect, but if there is something that's a little odd, like if the horsepower number is a little low for like the given amount of pulley size that we're working with, well, that's when we can look into having someone, let's check the back pressure of what the intercooler is doing and things like that to get them either what their goal is or beyond that goal,
That makes sense. So really the answer is you can pick the right supercharger, but it really needs to be based on looking at the system as a whole.
Whole package.
Okay.
And guys really, Centrifugal superchargers, much like anything, just like nitrous, I mean, or anything really, camshaft selection is
big.
Is massive.
Yeah, it's big.
I've had two identical customers with very identical builds, both LS based, both comparable in cubic inches. I think there was only about a 10 cubic inch difference between the two motors. Comparable heads, so like, rectangle port heads. It wasn't like cathedral versus rectangle or anything. And there was about a 600 horsepower gap between the two motors.
Wow.
At the same blower speed.
Wow, that's crazy.
They literally had the exact same pulley on each other. So it really comes down to showing how much
the VE of
the camshaft can affect. And really what it was is the one car had a camshaft that was bigger by paper, but had so much overlap in the camshaft that it was actually just blowing the boost right out the tailpipe, and therefore a whole bunch of horsepower was gone.
He was a tailpipe cleaner. I get it.
Yeah. So unfortunately it's kind of common. But I mean, really that comes down to dealing with cam vendors that have had there's guys that have a lot of centrifugal experience, just like there's guys that have a lot of turbo experience, and the guys that have a lot of roots blowers experience. So it's really finding the guy that would know the most there, or just calling up here. We'll give you general cam specs.
Okay.
By no means are we cam gurus or anything, but
that's okay.
We can get you in the ballpark. We can get everyone probably at the 85% mark. But for guys going for the ultimate last horsepower, well then you're just like you want to go to a top quality engine builder. You want a top quality cam designer.
That makes perfect sense. What we're going to do is, because the video is now at about 25 minutes long, to all the guys watching this, sorry we went a little long on this, but we're going to go ahead and end this video now, and then in the next week's Tech Tuesday, we're going to go ahead and pick up with Eric, and we're going to talk about the next 4 or 5 questions we have, which are going to be, can you go too big on your blower? Twins or single? That's a question. It's an odd one. Wastegate choices. Okay, I got some answers coming here. When should I upgrade? And then intercoolers and stuff. So that's going to be on our next Tech Tuesday video. We'll pick up right where we left off here with Eric from Procharger. So thanks for chatting with us for 27 or so minutes, Mr. Eric.
All right, not a problem, man. Anytime.
We appreciate it.